Hello everyone, we are going to learn about de Moivre's theorem. Statement: whatever be the value of n, positive or negative, integral or fractional, cos n theta plus I sin n theta is one of the values of cos theta plus I sin theta whole raised to the power n, or if n be an integer, positive or negative, the value of cos theta plus I sin theta whole raised to the power n is cos n theta plus I sin n theta, and if n be a fraction, positive or negative, then one of the values of cos theta plus I sin theta whole raised to the power n is cos n theta plus I sin n theta. Proof. Case 1. When n is a positive integer, we have cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2 is equal to cos theta 1 into cos theta 2 minus sin theta 1 into sin theta 2 plus I times sin theta 1 into cos theta 2 plus cos theta 1 into sin theta 2. Here I square is equal to minus 1. This is equal to cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2, because cos theta 1 plus theta 2 is cos theta 1 cos theta 2 minus sin theta 1 sin theta 2, and sin theta 1 plus theta 2 is equal to sin theta 1 cos theta 2 plus cos theta 1 sin theta 2. Similarly, if we multiply three products, if we multiply three terms, then cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2 into cos theta 3 plus I sin theta 3 is equal to cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. From the first two terms, we have cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2 into cos theta 3 plus I sin theta 3. Again, multiplying these two terms, we have cos theta 1 plus theta 2 plus theta 3 plus I times sin of theta 1 plus theta 2 plus theta 3. Again, taking product of four terms, cos theta 1 plus I sin theta 1, cos theta 2 plus I sin theta 2, cos theta 3 plus I sin theta 3 into cos theta 4 plus I sin theta 4 is equal to cos of theta 1 plus theta 2 plus theta 3 plus theta 4 plus I times sin of theta 1 plus theta 2 plus theta 3 plus theta 4. Proceeding in this way, we have the product of n factors, cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2 up to cos theta n plus I sin theta n is equal to cos of theta 1 plus theta 2 plus up to theta n plus I times sine of theta 1 plus theta 2 plus up to theta n. Now putting theta 1 is equal to theta 2 up to theta n is equal to theta in the above expression, then we have cos theta plus sin theta into cos theta plus I sin theta up to cos theta plus I sin theta up to n factors. This is equal to cos of theta plus theta plus theta plus theta up to n times plus I times sine of theta plus theta plus theta up to theta n times. So we obtain cos theta plus I sin theta whole raised to the power n is equal to cos n theta plus I sin n theta. Case 2. When n is a negative integer, let n is equal to minus of m, so that m is a positive integer. Then cos theta plus I sin theta whole raised to the power n is equal to cos theta plus I sin theta whole raised to the power minus of m, as n is equal to minus m. This is equal to 1 by cos theta plus I sin theta whole raised to the power m. This is equal to 1 by cos m theta plus I sin m theta by case 1, because cos theta plus I sin theta whole raised to the power m is equal to this, where m is a positive integer. Now multiplying numerator and denominator by the conjugate of cos m theta plus I sin m theta, we have cos theta plus I sin theta whole raised to the power n is equal to 1 by cos of m theta plus I sin of m theta into cos of m theta minus I sin m theta by cos of m theta minus I sin m theta. This quantity is the conjugate of this quantity. This is equal to cos of m theta minus I sin of m theta by cos square m theta plus sin square m theta, because this quantity gives, the denominator gives cos square m theta minus I square sin square m theta. I square is equal to minus 1. So this gives cos square m theta plus I sin square m theta. And this is equal to cos m theta minus I sin m theta, as cos square m theta plus sin square m theta is equal to 1. This can be written as cos of minus of m theta plus I of sin of minus m theta, and this is equal to cos of n theta plus I sin n theta, replacing the value of m in terms of n. Case 3. When n is a fraction, positive or negative, let n is equal to p by q in its lowest term, where p is an integer either positive or negative and q is a positive integer. Then cos p by q theta plus I sin of p by q into theta whole raised to the power q is equal to cos q times p by q into theta plus I sin of q into p by q theta by case 1, and this is equal to cos p theta plus I sin p theta. Here q cancelled, so this is equal to cos p theta plus I sin p theta. Therefore, taking the qth root of both sides, we see that cos p by q theta plus I sin p by q theta is one of the qth roots of cos p theta plus I sin p theta. But cos p theta plus I sin p theta is equal to cos theta plus I sin theta whole raised to the power p by case 1 and 2. Hence, cos p by q theta plus I times sin p by q theta is one of the qth roots of cos theta plus I sin theta whole raised to the power p. Thus, cos p by q theta plus I sin p by q theta is one of the values of cos theta plus I sin theta whole raised to the power p by q. Therefore, one of the values of cos theta plus I sin theta whole raised to the power n is cos of n theta plus I sin n theta. Corollary: since cos theta plus I sin theta into cos of theta minus I sin theta is equal to cos square theta minus I square sin square theta is equal to cos square theta plus sin square theta, as I square is equal to minus of 1 and this is equal to 1. Therefore, 1 by cos theta plus I sin theta is equal to cos theta minus I sin theta, and 1 by cos theta minus I sin theta is equal to cos theta plus I sin theta. Number 2, cos theta minus I sin theta whole raised to the power n is equal to cos of n theta minus I times sin of n theta, and this is equal to cos theta plus I sin theta whole raised to the power minus of n. 3. Sin theta plus I cos theta is equal to I times cos of theta plus 1 by I sin of theta is equal to I times cos of theta minus I sin theta, as I square is equal to minus of 1. So, I is equal to minus of 1 by I, or minus of I is equal to 1 by I. Next, to put A plus IB in de Moivre's form, let A is equal to R cos theta and B is equal to R sin theta. In the figure, R is equal to A cos theta and B is equal to R sin theta. Then A plus IB is equal to R cos theta plus I times R sin theta. This is equal to R into cos theta plus I sin theta, where R and theta are given by the relations 1 and 2, here 1 and 2. In general, A plus IB can be written as R into cos of theta plus twice n pi plus I times sin of theta plus twice n pi. Now, squaring equation 1 and 2 and adding them, we have R square cos square theta plus R square sin square theta is equal to A square plus B square, implies that R square is equal to A square plus B square, or R is equal to under root A square plus B square. Since R is distant, so R is taken as positive. Dividing equation 2 by 1, we obtain tan theta is equal to B by A, or theta is equal to tan inverse B by A. In the above representation, R is called modulus of the complex number or complex quantity A plus IB, and R is taken as positive. Theta is called the amplitude or argument of the complex quantity. The value of theta which satisfies 1 and 2 and also lies between minus pi and plus pi is called the principal value of amplitude. That is, if theta, value of theta is between minus pi and plus phi, then theta is known as the principal value of the amplitude. If theta be the principal value of the argument, then the general value of the argument is denoted by theta plus twice r pi, where r is any integer either positive or negative. Now, particular cases. 1 is equal to cos 0 plus I sin 0. Here this is 1 0. 1 is a real number lying on the real axis, x axis, and this point is 1 0. Here angle is 0. I is equal to cos pi by 2 plus I sin pi by 2. Here angle is, this angle is pi by 2. So I is cos pi by 2 plus I sin pi by 2 is equal to 0 plus I. This can be written as 0 1 along imaginary axis. Number 3, minus 1 is equal to cos pi plus I sin pi. This is given as, this is angle pi. Number 4, minus I is equal to cos 3 pi by 2 plus I sin 3 pi by 2. This point is minus 1 0, and this point is 0 minus 1 represents minus I is equal to cos 3 pi by 2 plus I sin 3 pi by 2. Here this angle is 3 pi by 2, 3 right angle. This is all about de Moivre's theorem and some consequences, some particular cases.